name is Bill Prin. I work at Google on cloud platform in our developer relations. Thanks a lot for Rudy for organizing and Eventbrite for hosting. Really great to follow up Andrew because big South fan because when I first discovered Django, it was great except migrations were terrible. And then I discovered South and I was like, why is this not just part of Django? And then 1.7 they made it part of Django, so yeah, it made my life a lot easier. So yes, Django. This being the Django meetup, we'll start with a Django app. I have a little AngularJS guestbook app that I'll show you in a little bit. We're using Postgres and Redis. Those are really popular databases and caching layers. You can also use Redis for queuing. When I was at this meetup last time, I heard someone call it the Instagram stack, I think because they have a blog post about it. My app is a lot like Instagram. If you just get rid of the pictures and friends part, you just add some text to a screen. So it's create and read. So once you have your Django app, you're wondering, how do I deploy it? So there's a bunch of options, like tons and tons of options. I'm going to show you one today. I tried to break them down and do these 3 larger categories, even though in reality things blur. But you have platform as a service. Heroku's probably the best known here. I have to give a shout out to App Engine, of course. But so why would you want to use platform as a service? Because it's really easy. You tend to just give it your Django app and hit the road, and they figure out all the hard details for you. Usually, if you're doing a web app, there's a bunch of problems that the same people are going to solve over and over again. And platform as a service usually provides that. The disadvantage is that you're usually locked into their way of doing things. You want to kind of go outside the rails and do something different from your web app, or you want to install a library that's not supported on that platform, you can sometimes run into trouble. So the second category I would say would be kind of a traditional VM setup or just on-premise physical machines. So this is the traditional way of doing things. People know how to do it. People are used to it. The disadvantage is that you either have poor isolation or poor resource usage, and by that I mean, so you can either run a bunch of your apps on the same VM, and then you can run into issues where they have different libraries, or it works, but you're trying to run chef script and things get crazy, or you can try to separate everything into different images. I'm going to save an AMI image or a machine image and spin these all up separately. The problem with that is that VM images are generally not portable. They take a long time to start up. They're not composable, and by that I mean sometimes you want 2 apps to run on the same machine. So we have a bunch of problems, and Docker comes along and gives us brand new problems. But there are a lot of advantages though. They start up a lot faster. We can run a bunch of them on the same machine, so it's more efficient. We can compose them, like I was saying. As Andrew was talking about, they're immutable, they don't change. So Docker is really exciting. Docker's not the only container solution, but it's by far the most popular. Big disadvantage is they're less proven. People are less used to them. I think, even if the traditional way is harder, people are just more used to those workflows. And there's still a lot of rough edges. Storage has been brought up. Security is another one where people can jailbreak out of containers. And so if I'm boring you at any point, I'm just linking to this blog post by Circle CI because it's really funny, and it's pretty much just making fun of everything I'm talking about. But this is from the perspective of someone with a Heroku app who's like, oh, am I doing it right? They're like, no, you need a Kubernetes cluster. And they're like, oh, I only have 1 service. And you're like, oh, what do you mean? You have an app, you have to have like 8 to 12 services. This might sound ridiculous to a lot of people, and if it is, and like a traditional setup on Linode or DigitalOcean or your Heroku or App Engine apps doing great, then you can pretty much ignore a lot of this stuff. But fortunately, I followed up Andrew, and he was pointing out that a lot of places do have a lot of services. They do have a lot of teams. They're embracing service-oriented architecture, and So we're gonna go to my terminal in a second, but we have a Docker, we have a Django app, and I'm gonna make a container for it. And my Django app's gonna be really simple. I'm gonna install a bunch of Python libraries and pip install all my dependencies into a virtual environment. I'm gonna kick off Django with Gunicorn, or however you say that. You could use Apache instead if you wanted. and then I'm going to build it. In these examples, I'm pushing to Google Container Registry. It's same as Docker Hub, but private Docker repos, basically. So I have that image, and now I want to run it on a cluster of nodes. I have a big cluster of virtual machines usually, but possibly on-premise physical machines, and you're going to get a bunch of challenges. You're going to get, how does it get scheduled onto an appropriate node? How does one container go where? And if that node fails, like how does it get rescheduled? How do I make sure that the node I get scheduled on has enough memory or has enough CPU or has whatever else I need? How is my container going to discover other services it needs, like a Postgres instance or another team's microservice that might be getting redeployed really fast? And that might have containers spinning up and down and coming in and out of existence. How do end users or my other teams know how to find my service? How do I scale it up or down? How do I make lots more containers? And how do I do that manually myself? And how do I have that automatically based on different metrics? How do I update it? How do I roll it back safely? How do I change it? How do I, if I have multiple images, I want to A/B test them, or I want to send out a few of them and canary test them before I roll it out to production completely? How do I do that? Where do I store passwords or SSL certificates? And how do I namespace my containers? Maybe I want to have a development and production completely separated. Maybe I want different teams to be totally separated. So these are a subset of problems, probably not even all of them, that Kubernetes attempts to address. And to some degree, Kubernetes is going to address those problems directly, and to some degree, it's going to provide a plug-in ecosystem to let different vendors or people or open source contributors solve it in different ways. So it's a container orchestrator. So the main thing is, given a bunch of containers, how do you move them around and plug them together? How do you network them together? It supports multiple cloud and bare metal environments. So Google makes it so we have a managed Kubernetes service called Container Engine I'll show you soon, but it runs on AWS. AWS is really popular, so it's probably the one that's going to work on best besides Google. And then it's open source, so people are running it all sorts of crazy places. You might run into different limitations depending on exactly where you're running it, but Google and AWS should be good. Google has been running containers in an internal system called Borg for a long time. So one of the reasons you might buy into Kubernetes is you just buy into Google engineering team's ability to use their experience from that to build a really good container orchestrator. And last but not least, it's open source. Again, you can go on github.com/Kubernetes and check it out. It's written in Golang. I know that has mixed feelings at Python meetups. But so Docker was written in Go. etcd, which Kubernetes uses, was written in Go. So you kind of have a whole Go ecosystem going there. So I'm going to start my demo, but I procrastinated and have not even merged this. When I publish these slides, I will get it to review. But if you're curious, if GitHub's back up, that's the link, github.com, Google Cloud Platform, Python doc samples. I have a directory container engine that have some merge tutorials, actually. But this one, we're going to deploy Django and Postgres and Redis on Kubernetes right now. I'll go over more of the Kubernetes concepts, but I thought it's useful to kind of like actually walk through deploying an app and then go back to the Kubernetes concepts. If there's any problems, get on GitHub and mention me, and I'll fix them. And yeah, so this is all based on Container Engine. There will be minor differences or big differences depending on where you run it. Like AWS, the biggest difference would just be I'm going to use a persistent disk for storage. On AWS, you would use an EBS volume. So I think AWS and OpenStack and Google Cloud without Container Engine should all work fine. Places that don't have load balancers and all that, you might also run into some issues. So that's just FYI. So yeah, let me show you my app. This is my, is this font big enough? So this is my Django setting. So because I don't want to make things too complicated, I have this NoDB environment variable, and that's just going to run it without a database and without a cache. And then I have hooking up to Postgres here and a Redis master and a Redis slave. If you just want to look at my views really fast in guestbook, I have like a little I'm not using Django REST framework. This is just kind of a hand-rolled, you can get all the messages or you can post a new one. I use a cache as a visitor count. And You'll notice in these settings, I get my configuration from my environment. I think Docker, Kubernetes kind of all took a page from Heroku there in terms of how things get configured. And you'll see what I mean in a second. So if I go to my guestbook app, I can run it locally, run server, and go to localhost. This is SQLite, so yeah, grade 3, I can submit it. My cache gets updated. Okay, so I'm going to, and if you look at my Docker file, I extended it from just one of the bunch of Python runtimes. Like I said, install stuff. Currently I'm gonna have this NodeDB setting on, and so I'll do a make build, and then a make push. Now, the reason I'm doing make files is because I'm basically just using them as an easy way to alias shell commands. These are all like Docker build and Docker push commands, but a lot of times make file just makes it really easy to bundle aliases. So I'm pushing. Where did my slides go? Well, I lost track of my slides. Oh, awesome, thank you. So yeah, this Coop Control command is gonna be your main way to interact with Kubernetes, but everything in Kubernetes is an API. Brendan Burns, one of the lead engineers, has said that he really thinks that Coop Control is not even what you're gonna be using if you really buy into Kubernetes. You're gonna be using REST clients and doing this all through scripts, but the command line tool is what we're going to demonstrate today. So Coop Control get, I can like show my pods and my services, describe. Coop Control logs will show the logs in a container. And then just like Docker exec, you have Coop Control exec. Someone just asked about like how do I run my manage.py in a container. I'm actually going to do exactly that to run my migrations, thanks to Django's awesome migrations thing. So first, I'm just going to, now that my container has been pushed up, I'm going to go back into Coop Control, create -f, guestbook, and then, or no, not guestbook, Kubernetes configs. And that's going to create my front end. Now, really quickly, I'll look at this. You can look at this on your own, but I'm creating a replication controller, and I'm creating a service that's type load balancer and maps port 80 to my container port, which is 8080. Now, if I do Coop Control get services, because I specified that, you're going to get an external IP. That is provisioning an L7 load balancer, so that usually takes a few minutes. And then I do Coop Control get RC. That's my replication controller. You'll see I have 3 replicas, and that's 3 versions of my container. And then I can do Coop Control get pods. Oh, wow, yeah, thank you. So yeah, people, I don't know what people can see. So get services, I have my front end service, get pods. I have 3 replicas of my container running, and get replication controller. We'll just show my replication controller, and I'll talk about what those things are right now while that load balancer provisions. So yes, create a replication controller. That controls how many instances of my container I have. Now, I talked about the word pods there. Now, pod can have multiple containers. Earlier, I talked about composability of containers. So sometimes you want to put multiple containers in one pod. Generally, containers run one process. So a good example would be you have a Django web server, and you have a separate container that goes with it that just does a git clone or git pull from a repo. And then whenever you push to that, it's going to git pull into your server, and then you just set up push to deploy. And what's nice about that is the pod that does the syncing of the repos with the Git repo, you could throw that on a Rails project, and you could throw that on whatever, a Node project, and it's going to be the same container. So that's what people talk about, the composability of containers, kind of thinking about, kind of like object-oriented programming, except with apps that you're putting together. So we created a service, and that, because we specify as external, we'll provision an external IP that's going to map to those pods. But if it wasn't external, it would still have a virtual IP. Kubernetes creates all these virtual a virtual network on the private network, and services select pods based on their labels and routes traffic to that. So this is going to be the architecture diagram now that I just deployed this front-end service using my, again, SQLite and the in-memory cache. So service should be ready by now. So now I have this external IP, and I can check it out. My guestbook app should be there. It actually took my SQLite database because I just let it get added to the Docker container. And we might be able to see this, but because they're all using the in-memory cache, and there's 3 different containers with different memory, this will be like sometimes increment and then sometimes not increment. See, it's 2 times, still 2. So we want to hook that up to an actual Redis cache. So the next part will be creating Postgres and creating Redis. Redis is actually the simpler of the 2 because there's no storage and there's no secrets. So for Kubernetes config, so I'm just going to create a big Redis cluster, and I'm creating a Redis master that's read-write and Redis slaves that are read-only. And fortunately, there's a Django plugin that makes that really easy to set up if you looked at my config earlier. And those images are pretty much Redis, but with a few switches just to make sure the slaves are talking to the master correctly. So Coop Control get services. We'll see my Redis master and Redis slave. And what's nice is now is that my front end, I told you that I use those environment variables. Well, those environment variables will be auto-populate in all my containers. Anybody who looks for Redis master service host is going to get mapped to this internal cluster IP. And that's going to use what's called the Coop proxy, which does IP table magic to route it to the correct node, which will then know how to route it to the actual correct container. And it's going to round robin around the different containers. Any container that has a label that says it implements whatever Redis master is looking for. So next we'll do Postgres. And before the demo, I created the cluster, and I also created the secrets. You create those as objects, and then my Postgres image is just going to read in those secrets into some environment variables. But otherwise, it's mostly just from Postgres. And again, creating a replication controller for Postgres and a service for Postgres. And the replication controller for both Postgres and the Redis master are going to stick to one pod because the disk can only be read or write by one pod at a time. And if you're saying my Postgres is not highly available, you are correct. And figuring out highly available Postgres and Kubernetes would be a really awesome project. I just wanted to demo something simple for you today. And for production reasons, if you're in production, I would still probably not run your databases in Kubernetes unless you have some confidence that you figured out the correct way to put them together. But for development purposes and just for checking out Kubernetes, we can do it. So just really quickly look at my Postgres config. It's, again, a replication controller, given my image, and I mount a persistent disk, in this case a GCE persistent disk, and I mount those secrets. And now I need to kick off a script to initialize my database, which I put into the Docker image, make DB setup. So that's doing Coop Control exec, and then that initdb script I put in there. And now, again, thank you, Andrew. We're going to make migrations. And that's going to do the thing I said earlier, Coop Control exec, Python, manage.py migrate. I guess I already applied my migrations. So I'm going to Coop Control scale my front end back down to 0. And then I'll scale it back up so it gets all the right environment variables. So a really nice feature of Kubernetes is rolling update, which will carefully replace one pod at a time with your new image. It takes a little longer, which is why I just took the short way and just scaled to 0 and scaled back up. But let's see if everything is good, and that worked. So we see everything's running. I scaled down, so those are the ones that are terminating here, and then I scale back up, which is why you see some running. And I have my Redis master, I have my Redis slave, I have Postgres. So hopefully this is all deployed and will work. Coop Control get services. And yeah, external IP here. now this should actually, oh, right, I forgot a step. Okay, I forgot to, before I rescaled my front end, just rebuild it without this NoDB environment variable. So I'm gonna do another make build, and then another make push, and then do what I just did. And it should work. So I'm gonna jump to my slides for a second, just to reiterate a lot of stuff I just said. So yeah, you can do scale a pod, you can rolling update it, stuff I talked about, services. Like I said, we could use external services instead of just deploy them. Again, Postgres, volume, and secrets. My Redis cluster didn't need either of that. I have 2 services. So this is our new architecture diagram. Another good project that I or someone else want to do is, given a Kubernetes cluster, generate a good diagram. So I have those blues. The blue are the services, the teal things. The green are the pods. The boxes are the actual VMs. And the orange are the replication controller. So those orange boxes are controlling how many of each green box there are. And the blues are kind of these abstract concepts, because any of the green box can say, oh, I want to talk to the Redis slave, and they just look for that environment variable. Or there's also a DNS system that you can use for service discovery. And so yeah, so the orange are controlling how many, and both the replication controllers and the services control pods based on labels, which are kind of just arbitrary key value pairs. So you could say environment dev or name Redis or whatever else you want to call it. So just some good use cases that I like. So Jenkins on Kubernetes is really fun, because to me, I've had miserable experience running Jenkins before on VMs, because the 2 things you really want are isolation and scalability. By isolation, I mean, I don't want to write crazy things because 2 of my tests need the same port. I just want to use that port. If one of my tests goes crazy and starts going nuts with the CPU, I don't want that to ruin all my other tests, et cetera. So Docker gives you that. But then you want to have lots of Docker containers. And Kubernetes gives you that, lets you talk to them. This is actually the repo that I actually use for it, but it links to better tutorials. But I'm currently running all my tests in Jenkins and Kubernetes and having much better time. So I currently use a replication controller to spin up a bunch of slaves that I want to run the tests on. But the way I want to switch it to is to just have a generic build agent that starts a Docker plugin to build up whatever image you want in the test config. And then that lets you build Docker images that you can then deploy to Kubernetes via the API. So you get like Docker, in Docker, in Docker. I'm still wiring that all together, but it's a really good use case of Kubernetes. And then, as I was saying before, the service manages pods based on their labels. So if you want to do A/B or canary testing in Kubernetes, what you could do is you could A/B testing. You could have 2 different replication controllers. They both have the name of the app you're talking about, but they maybe have a different other label that the service isn't looking at. So the service is going to map all the same traffic to both those types of pods. And so if you had that 50-50, that might be an A/B test. If you had that like 90-10, that might be a canary test. What I'm actually going to demo today, because it excites people the most, is autoscaling. But this is a beta feature. It's like 70% of the time, works every time type situation. But I think the demo will go well today. So there's 2 kinds of autoscaling you have to think about. You have to think about pod autoscaling, which is, my front end pods are using a lot of CPU. I need more of them. But then node autoscaling, which is I need more machines to actually run these pods on. And Kubernetes concerns itself with the pods. And then the node autoscaling is run by whatever cloud infrastructure you're running on. So Google has an autoscaler, Amazon has an autoscaler. You're going to rely on those, and Kubernetes just knows how to talk to those nodes that, oh, you added to my group, you're eligible for me to schedule a pod on. My load test is going to be really simple. I just curl my endpoint. I have a link to something that does uses Locust, which is like a real framework, and does cooler stuff. So my autoscaling demo, I'm going to do Coop Control, create -. Let me just show you the Docker file really quick. Load test image, Docker file. Again, like I said, I do while true, curl, and I'm using the DNS of my front end. So this is the DNS name it's going to find. And I have this compute endpoint to simulate CPU load. CPU is probably not actually the metric you want. You can use custom metrics. It's just really easy to demo, so that's what I'm using. So I do Coop Control, create -f. load test image, or no. Once again, Kubernetes config, load tester. Oh, right, and I don't think I ever took a look at my new service before I load test it. Coop Control, scale front end, scale replication controller front end, replicas equals 0. Dash that front end, some typos. Equals 0, not equals, programming too much. Now I'm going to scale it back up the same as I did earlier. And as soon as those pods are ready, we should have a cluster that actually is talking to Redis and Postgres. Get services. Okay, so now we have a fresh database, hello world, and my cache is actually, oh, I actually know, make migrations. Okay, before it wasn't connected to the database, so it didn't know how to do the migrations. So now we actually ran our migrations. Now it should actually work. Hello world. Yeah, great. Okay, so on to the load test. So I'm going to go ahead and create my load image. And oh yeah, I already created it. So get RC. So I have one of my load testing. I want to spin up some CPU, so I'm going to Coop Control scale RC load. Let's give it like 30, which worked earlier. And just let me show you my make file for this make autoscale command. So again, this is gcloud. This is the Google Cloud command line tool. This is setting autoscaling for the nodes. And then Coop Control autoscale for the pods. Everything in Kubernetes is a REST API, so actually this just creates a horizontal pod autoscaler resource. So do make autoscale on, and we just spun up a ton of traffic hitting that CPU heavy endpoint, but this can take a while to kick off. By the way, I started with 3 nodes, and we had 3 front-end replicas. So this can take a little bit to actually set up autoscaling, so I'm going to finish my slide deck, and hopefully by the time it's done, we'll have way more nodes and pods. So yeah, this is that horizontal pod autoscaling resource. So yeah, so this is kind of my summary. You should deploy Django on Kubernetes if you love containers, basically. And especially if you want to deploy Django in microservices environment. Kubernetes is very much in the microservices community. If you buy into microservices and you think it's the way forward, you'll like Kubernetes. If you still think monolithic is the way to go, you probably won't. And if you want a toolkit that solves the hard distributed systems problems and let you design the platform, what I mean by that is really, when you should not, is if you're looking for a platform as a service, that's not Kubernetes. But Kubernetes is it makes it really easy to kind of like design your own platform as a service. I'm going to give you some examples of a bunch that are in fact doing that. I know like a ton of people are using Kubernetes because it lets you, you want to build a CI system, really easy to build it. You want to build a Heroku clone, really easy to build it, and lets you focus on kind of the design. But it doesn't come with many of the features you'd expect with a full like web app pass. And yeah, if you don't buy into containers and microservices, or more importantly, if like they really wouldn't help you that much, and you have some small side project and you have some good hosting for it, you're not doing anything wrong by not embracing containers and microservices. So I just want to go through some alternatives really fast. And again, a subset of them, but I think these are the 2 biggest ones you'll hear about. Docker Swarm is similar. Biggest advantage is it's built by Docker, so it's going to be pretty much the same API, same tool chain, send me everything. The disadvantages is a lot of the stuff I'm showing you today, like secrets and replication controllers, you're not going to see. And again, Brendan Burton's comparison, Kubernetes is more about the cluster. Docker tries to kind of abstract the Docker API to a cluster, which doesn't always naturally fit. But Docker Swarm, interesting to keep an eye on for sure. And Mesos is also pretty popular. I think Airbnb and Twitter use it, but I'm not sure. But definitely proven in production. People run huge clusters of it. And it can also hold like old school big data workflows. The disadvantage is it's like really complicated. It's resource intensive. You got to run Zookeeper and a bunch of Java stuff you don't want to run. But if you already have a Mesos cluster, some people like Kubernetes and they like the Kubernetes abstraction, so they're working on running Kubernetes on Mesos, even replacing the Kubernetes scheduler with the Mesos scheduler. So that's more of like an experimental area, but another pretty interesting spot to keep your eye on. So these are some companies I'm just gonna give shout outs to. Deis, I went to talk by them earlier this year. They are using Kubernetes to build an open source platform as a service. They're all open source, so if you want to check out also, and it's a Heroku inspired path. So if you want to basically check out an open source Heroku built on top of Kubernetes, there you go. Gondor is a pass that's all Django focused. So they just announced they're on Kubernetes. Storage, Kubernetes provides a lot of options for, but Flocker is something that's trying to, talk about highly available systems and all that. They're working on tool chains for that. And Sysdig provides a lot of analytics and information about containers. A lot of current metrics and analytics are still built around the VM model, so Sysdig is trying to dig into the actual underlying containers. Kubernetes open source. I showed you container engine today. Don't think about cluster setup. There is a script called kube up that you can run for like Vagrant or AWS and have a cluster really quick. But I've heard, and I don't have a ton of experience with cluster admin, Kubernetes admin can still be a little tricky. Same reason you might want people to host your MySQL. You can pay Google to host your Kubernetes. Actually, sorry, Container Engine is actually free besides the node cost, up to 5 nodes. So it's pretty much just cost the nodes. And like I said, some passes, and you can run some different distros. It's open source, Kubernetes.io, GitHub Kubernetes. There's a Slack community. You can check it out, Twitter. Just to give Google Cloud some quick plugs, GCP Next is a big conference, March 23rd, 24th in San Francisco. We also have a Slack community. Just wrote a bunch of guides on running Python stuff on Google Cloud. I'm about to release a bunch of Django guides, and that's my thank you. But let me just check this autoscaling and see if that worked, and then I'll take Q&A. So, yeah, so before we had 3 nodes, and I just did the nodes, and you'll see now I have 10, which is the max I asked to spin up. And replication controllers, you see front end went up to 15, which was also my max. I started at 3, if you remember. So yeah, autoscaling worked and went up. But again, still a beta feature. Definitely check it out. Definitely don't rely on it yet, but it's pretty exciting. Okay, that's all. Q&A? Thank you. Okay, the question is, what's the story about user access control inside a Kubernetes cluster? There's some basic auth plugins right now. I think you can use, again, everything's a REST API, so you can use HTTP auth, and you can, I think there's a Kerberos plugin. But you can check it out. There's some solutions to that. It's something that's being developed, but I think it's one of those things where people do auth in a lot of different ways, so you're going to see a big plugin ecosystem around it. But yeah. Other questions? Right, so the question is, how are you isolating people within Container Engine? How do I know that I'm not going to break out my container into some other company's containers, if I understood your question right? So Google Container Engine, like I said, it's just Google. It runs right on Google Compute Engine, so it's not like you can share a VM. Like the minimum you can have is a 1-node cluster and 1 VM. So you have isolation because that's your VM, and same way any other cloud provider. So it's not a system where, so I can even SSH and like run Docker PS on one of these and see my containers in there. So yeah, that's how isolation is done. How does it support container migration? Right, okay, so you're talking about running, so there's a project, you're talking about running multiple container clusters. There is a project to address exactly that called Kubernetes, and they also want to work not just on 2 container engine clusters, but like a container engine cluster and then an on-prem cluster. Like that's a really important use case. So I don't know much about it other than you should Google Kubernetes. I'm pretty sure that's public information, and you can read more about that. Yeah. The question is there plans to make an overlay network where containers and different nodes can talk to each other? So it already, I'm not sure if it's technically called an overlay network. Already containers on different nodes can talk to each other. That's the whole point of that service abstraction. They all have virtual IPs on the 10.network, so it's a private IP space. And I do know that there's a bunch of products related to that, Weave and Flannel. So those would be the terms to Google for more information about that. But if I understand your question correctly, that's pretty much one of the networking containers together and giving you that IP space and knowing how to get from one container to get another service is actually one of like the main value adds and like what Kubernetes does. Yeah. Yeah, so because the question is, why would I use Flocker instead of the built-in storage features? First of all, you should just go to Cluster HQ site and find out. But storage, again, like I said, so I mounted a disk for my Postgres example, but if that disk gets corrupted, what are you going to do? And then another big issue is if your pod dies, how does it get reattached to the right, how does the right volume get reattached to the right container? Flocker, that's like one of the main things Flocker is built to do, is make sure the right volumes are always lined up with the right pods. I think Container Engine should pretty much do that for you, but again, there's still like some rough edges. I wouldn't run your production databases in Kubernetes yet, and Flocker is a tool chain to address that. And then another thing about storage is that storage, again, is like a plugin thing. So there's some subtle differences between how GCE persistent disk volumes and how Amazon EBS volumes work. So sometimes these things are solved in Container Engine, but there's products to smooth out the experience in other environments. Yeah. The question is, can you attach to a Docker container on Kubernetes without exposing a Docker socket? The answer is I honestly have no idea. Off the top of my head, I can't think of a way, but I also imagine people could figure it out. Yeah. Any other questions? If you need to persist the data, then you need to store it on some sort of volume. So my default go-to answer would be, I know Redis has some persistence settings, and I would say attach a persistent disk and use Redis basically as another database. But yeah, I'm not 100% sure. Yeah. I mean a Kubernetes volume, and for Kubernetes volumes, you have GCE persistent disks, you have EBSs. You can also use like a Git repo, a GitHub repo, or NFS mount. There's a whole bunch of plugins. You can go see the list of them. But if you want persistence in Kubernetes volumes, and there's a related concept that's almost the same thing called persistent volumes, that persistent volumes are their own resource rather than being attached to a cluster. So that's actually a slightly better way to do things, but I want to keep things simple. Yeah. Any other questions? Doesn't look like it. Well, thanks a lot for having me and listening to me. It's really fun.